Algebra I, 11.5c, Operations with Rational Exponents. Okay, now we're in 11.5c. If you haven't seen video 11.4c, that was 3 videos ago, you might need to watch that one first because that explains what rational exponents are and how to simplify them. We've done a few videos since then, so you might get lost, but you're very welcome to try watching, okay? There's a link to get to 11.4c in the description of this video. So if you want to just click on that right now, you can go there. The rules for operations with rational exponents are the same as the rules for integer exponents. What that means is when we have an exponent that's a fraction, we use the same rules that we use for negative or positive exponents, integer ones. So the product rule for exponents says when you've got a to the m power and you need to multiply it to a like base, a to the n power, we just add the m and the n together. Quotient rule for exponents says when you've got like bases, you can just subtract them, can't you? If that's a 3 and that's a 2, then we get a to the first power. The negative exponent rule says if you've got a negative exponent, you can turn it into a fraction. And that gets rid of the negative exponent. Now it's to the positive m, but it's under a 1. Then we have the 3 power rules for exponents. The first one says that if we have an exponent on the inside of the parentheses and there's one on the outside, then we multiply those together. We don't add them, we multiply them. When the a and the b are inside of parentheses and there's an exponent on the outside, it means we distribute that exponent to each one. That's the second power rule for exponents. And the third power rule for exponents says when we've got a fraction or a rational number, we distribute that exponent to each one. So we've got a to the n over b to the n. And don't forget, a to the 0 power with a 0 exponent equals a 1. That's the 0 exponent rule. Remember that one? All right, so we're going to use these rules to help us, okay, to do operations with rational exponents, all right? So we can simplify each expression, if it's possible, and write the expression in radical form. So I color-coded this to help you. I hope you can see color because I know a lot of people can't, but maybe even the shade will help. If we've got 12 to the 6 over 8 as the exponent, the 6 over the 8 can be reduced, can it? It can be simplified to 3/4. And you can see that the denominator ended up going out here as the index, and we put the numerator here as the exponent underneath the radical sign. See how we did that? All right, so that's the product rule for the exponents. Here, we're going to just add these together, okay? So if we've got 5 and the exponent is 3/2, and we're multiplying it to 5 and the exponent is 1/2, just like we did over here, when we've got the exponents like this, okay, we're just going to do 5 to the 3/2 plus 1/2. See? It's got a like base. And when it's got a like base, we just add them, right? So they both have a 5 for a base, so we're just going to add the exponent. And 3/2 plus 1/2 is 4/2, and 4/2 simplifies to a 2. So now we've got 5 squared. Well, that equals 25. See how we did that? Now we've got it so the denominators are not the same. Here's x to the 7/9, and this is x to the 1/3. Now the bases are the same, but we need to get these denominators for the exponents the same so that we can add or subtract them, right? Because we can't do it until the denominators are the same. So 1/3 becomes 3/9. So now we've got 7/9 take away 3/9. See? And the quotient rule for exponents says we subtract. So 7/9 take away 3/9, we've got x to the 4/9. And if you look, we put the numerator inside here, and we put the denominator on the outside as the index. See? See how we did that? We found a common denominator, we subtracted, and we wrote it with the 9 denominator as the index, okay? Now take a look at this one. This is pretty long. This is the problem. it says we've got x to the 3/5 power times x squared over 2, and that is to the 2/5 power. So it's basically x to the 3/5 power over 1, right? So that when we're multiplying the fractions, we can just go straight across, right? Make it easier on our eyes. Well, this x squared to the 2/5 power, which is what this means, because this 2/5 is going to go to both the numerator and the denominator, right? That's the power rule for exponents, the third power rule. That's the one down here, where if there's an exponent outside the parentheses of a fraction, it goes to both of them, okay? So this 2/5 exponent is going to go to both of these. So that means now we've got x squared raised to another higher power of to the 2/5, see? And we multiply these and we get x to the 4/5. See that? See how we did that? And this stays the same. So now we've got x to the 3/5 over 1 times x to the 4/5 over 2 to the 2/5. And we add these together, so we end up with x to the 3/5 plus 4/5. That gives us x to the 7/5, and it's all over 2 to the 2/5. See? Because it's times 1, so it stays the same. So now we're right here. So now, as we did in the last video, if you haven't seen it, you need to click on the description of this one and watch that one to understand, or you're going to be lost. We rationalize the denominators. And because this has a 2/5 here, we need to find something to add to this to get rid of this exponent. And because the product rule says that we can add exponents, if we add a 3/5 to this by multiplying this whole thing to a 1 as not the denominator over the denominator, but as to 2 3/5 over 2 3/5. See, that makes a 1. Remember in the last video, we said you don't need to multiply it by denominator over denominator. We can find something that'll make a perfect square, right? So if we multiply this by 2 with 3/5 exponent, we're going to be able to add the 2 and 3 together to get a 5 over a 5. See? And what's going to happen is the top one is going to be 2 to the 3/5, x to the 7/5, and the bottom denominator is going to be 2 to the 5/5. See? Because it's got the same base. We don't multiply these. It's just like this one, a to the m times a to the n. We keep the same base, and we just add the exponents. So we're just going to add the exponents here and keep that base 2. Now we've got 2 to the 5/5. Well, 5/5 is a 1. That means 2 to the first power, so we've got a 2 here. So now this is what we've got, see? And we can have this written in radical form like this, and this is how I did it. Now remember, 2 to the 3/5 power. When we write 2 to the 3/5 power, it means this, right? We can put the 3 inside with the 2, and the denominator 5 can be the index. That's what we've been doing, right? You put the numerator inside underneath the radical sign, and then the denominator goes outside like the index, right? All right, so that's the 2 with the 3/5 power, okay? That's that one. And then the x to the 7/5 could be written like this, right? The numerator inside underneath the radical sign, and the 5 is the index. So they both have 5 for an index, don't they? So what we can do is we can combine that and put 2 to the 3rd x to the 7th underneath the radical sign with the 5 as the index, and we put a half out in front. See that? Now that's written in radical form. Now if you're really confused, you need to go back a couple videos, maybe to 11.5a or farther. You can look through the list of videos in this description to see if there's any that can help you. If not, you might need to go back several and just Start watching them again. And if you haven't seen any of these because you just happened along my video and you're confused, you might want to go back to 11.1. And our next video, 11.6a, we're going to add or subtract radicals, all right? After that, 11.6b, we're going to talk about conjugates, okay? So we're getting farther and farther along. All of these videos are one click away, all right? Just take a half an hour of your time. You can watch them all, and you'll catch up, and you'll know what's going on. All the holes in your education will be filled in, all right? I'll see you next video. Bye.